This is part 1 of polynomial inequalities. We're going to start by going through and reviewing how to find all of the key features for a rational function, including all of the asymptotes, intercepts, things like that. So please pause and see if you can locate all of those and then come back and see if you got the right answer. We're going to start with the vertical asymptote. Vertical asymptote, you take the denominator and set it equal to 0 and then solve. So x plus 3 equals 0. We get x equals negative 3. Next, we're going to find the horizontal asymptote. You always locate the largest degree to find the horizontal asymptote, and then you divide by the same degree, which doesn't exist in this case. So there's no x squared term on the bottom, so we'd have to say 0x squared, which tells us there is no horizontal asymptote. But that means that maybe there's a slant asymptote. So you can either go ahead and find your x-intercept and y-intercept, or you can go ahead and find the slant asymptote right now, so you don't forget. Slant asymptote we find by doing long division. So x plus 3, and we have x squared plus 0x, put that placeholder in, since there's not an x term. And then we divide. So x squared divided by x is x. Then we're going to multiply. X squared plus 3x. We subtract. So we get negative 3x and then bring down the negative 1. Then we're going to do the same thing again. Divide. X into negative 3x, which is negative 3. Negative 3x minus 9. And then subtract. Negative 1 minus a negative 9 is really plus 9. So we get 8. But even though that's our remainder, we're not going to use it. Our slant asymptote is y equals x minus 3. You do have to have that y equals because it's important to indicate that it is a line, most always in slope-intercept form, so we could identify that the slope was 1 and the y-intercept was negative 3. Lastly, we need our intercepts. So our x-intercept we find by setting our numerator equal to 0 and solving. When you take the square root of 1, you get plus or minus 1, which tells us we have two x-intercepts. And we want to write those as points. So negative 1, 0, and 1, 0. And then we have our y-intercept that we find by putting zeros in for all of the x's in the equation. And that gives us, looks like negative 1/3. We also write that as a point, 0, negative 1/3. So we have 3 intercepts that we could use for graphing, and we have 2 asymptotes, a vertical and a slant. Today we're going to switch gears and get away from graphing on 2 axes, and we're going to kind of go back to a number line, so just graphing on 1 axis. So we are going to start by solving the inequality, and then I'll kind of walk you through how we're going to find the solution in interval notation that we can then graph on a number line. Okay, so on this first one, you're going to start by factoring. And these both have an x in common, and we also never want our leading coefficient to be negative. So we're going to pull out a negative x. So we end up with x minus 3. When we factor, we'll use the zero product property, meaning we'll set each factor equal to 0. So negative x equals 0, and x minus 3 equals 0. Which tells us that we have 2 answers, x equals 0 and x equals 3. All right, we're going to take those 2 answers and we're going to put them on our first of 2 number lines. And hopefully when you look at this function here on the left, you see the square. And you know that that makes a parabola. Also, hopefully, because we studied transformations, when you see this negative, you know that that's a reflection over the x-axis. So here we have a parabola reflected over the x-axis, or in other words, a parabola that opens down. So you're going to draw a quick sketch of a parabola opening down that goes through the 2 points that we just located. Next, we need to determine, are we interested in the top portion of the graph or the bottom portion of the graph? And the way we do that is by looking at this inequality. This inequality says greater than or equal to 0. This number line right here represents 0. So greater than 0 would be the top portion, less than 0 would be the bottom portion. Since this says greater than, we care about this top portion. All right, so far all of this is just work and helping us kind of sort through what we have here. None of this is our answer yet, but we're getting to that answer part. We need to describe that top portion in interval notation. Well, this top portion starts at 0, and since it was an equal to sign, it'd be a closed circle or a bracket, and then it goes all the way consecutively until it gets to 3. So 0 to 3, both with a bracket because of that equal sign. So to describe 0, 3 on a number line, notice we're drawing a separate number line here, not the same one we just used. But we go 0 to 3 and we'd shade all the numbers between 0 and 3. This tells us that any number from 0 to 3 inclusive that we put into this equation would give us a value that was greater than or equal to 0. Well, let's try another one. X squared plus 5x minus 6. All right, so just like last time, we are going to start by factoring. So we're going to factor x squared plus 5x minus 6. That's x plus 6 times x minus 1. So we get x equals negative 6 and x equals 1. Just like last time, we're going to take this first little line and put those two values, making sure that you put the lower one on the left. This time, there's not an equal to sign, so they would be open. We have another parabola because it's an x squared, but it's positive, so it would be opening up. Again, all of that so far is just kind of the necessary work we have to think through before we can get to our actual answer. Okay, so we need to know, do we care about the top portion of the graph or the bottom? The top represents a greater than 0 and the bottom represents less than 0. This says less than 0, so it wants us to select the bottom. So to describe that bottom portion in interval notation, we have an open circle, so parentheses, negative 6 to 1 parentheses. To put it on a number line, we'd say negative 6, open circle, 1 with an open circle, and we would shade in between. And then this part down here, the interval notation in the graph, is your answer. These other pieces are your work, and you do need to show those. All right, let's take a look at number 3. 2x squared plus 5x is greater than 3. Now we still want to start by factoring, but before we can factor, we have to move everything to one side. So 2x squared plus 5x minus 3. I had to subtract that 3 over. And then to factor this, we'd have to split the middle because our leading coefficient isn't 1. So 2 times negative 3 is negative 6. We need something that multiplies to get negative 6, but adds to get 5. Well, that would be positive 6 and 1. So we split the middle, and then we do grouping. So we have 2x times x plus 3. Take out a negative, x plus 3. Hopefully you guys are super comfortable and good at factoring by now. We've done it all year long. So those are our two factors. If we set each one equal to 0, we would get x equals -3 and x equals add 1 divide by 2 1/2. Like we've done on the two previous questions, we would take those two numbers and put them on a number line. My 1/2 didn't quite fit in there. There's no equal to, so they're going to be an open circle. Again, it's a parabola. Again, it's positive, so it's a parabola that opens up. All right, so this time we want the portion of the graph that's greater than 0. So that's the portion above the line. So if I want the part that's greater than 0, I'm looking for these two sections of the graph. Notice they're not connected to each other. So when I go to write my interval notation, I need to describe them separately. So this one on the left would go from -∞ all the way to -3. And the one on the right starts at 1/2 and then goes to infinity. So on a regular number line, I'd have the same two numbers, still both with open circles, but the part that I would shade would be all the way to the left and all the way to the right. And all of that is determined by what the inequality says. So we could do this entire problem. Here, let me go ahead and box in my final answer here. We could do this entire problem if the exact same, but if this said less than, then we would look for the part below the line and our final answer would be completely different. So it's all up to what this inequality says right here. Greater than, we're looking above the line. Less than, we're looking below the line.